Welcome everybody. My name is Carlos Rodriguez. I am a 7th grade teacher here at Myra Green Middle School. It's my second year teaching, and those of y'all that are included in this meeting, you already should know who I am by now because we teach right across the hall from each other. I want to send a special thanks to you, Coach Acuna, and I want to spend also a special thanks to you, Mrs. Elisa Garza, for joining me in today's training for Unpacking the TEKS. In today's agenda, we are going to be going over what are TEKS, where do they come from, what does it stand for, who sets these TEKS, and how they set themselves apart from the other national standards. What are the structure of the TEKS? So breaking it down from its most broadest point all the way down to its most specific point. What TEKS we will be focusing on, and if your eyes are wondering, you can see at the bottom that I already included the TEKS that's going to be coming up later in the agenda. We're going to be focusing on TEKS 8.2a and TEKS 8.2e. We will be unpacking the TEKS. So unpacking, which means to break down, we were going to be breaking down the TEKS from, like I said before, its most broadest point all the way down to its most specific point, and so that way we can thoroughly see what we have to do to apply these TEKS in the correct manner and make sure that we're hitting these TEKS at very, very important points throughout the year, so that way we do not leave one part behind and give more emphasis to another. That way we're streamlining everything to make sure that everything goes and flows rather well. We are also going to be looking at some background data for application of these TEKS. So we're going to be reviewing some test scores from years before to see how these two TEKS can help improve scores and to push our kids up to the mastery level where we all want them to be. And lastly, we're going to be going over the importance of TEKS 8.2a and 8.2e by looking at some research-based practices. And we are also going to be including how these TEKS will also help not only in the science realm, but how they will also help in our other core subjects as well. First, we're going to ask ourselves, what are TEKS? TEKS are, as stated by the Texas Education Agency, the current standards which outline what students are to learn in each course or grade. They are called the Texas Essential of Knowledge and Skills, or TEKS. Years ago, we were all under the Common Core standard, which these standards were brought on by the federal government, and for all schools in America, they were to be taught these Common Core standards. Over time, the state of Texas, as well as a few other states, have opted out of the Common Core standards, and we have adopted our own standards, which are going to be labeled as the TEKS. Now, TEKS are organized by a numerical system that helps to break them down by grade level, knowledge and skills, and student expectation. So when you're looking at your TEKS, whenever you're planning a lesson and you're able to see where you need to hit your TEKS, you're going to run across something that may look like this example. It says 7.2b. Okay, 7 stands for the grade level. So in this case, we're going with 7th grade. 2 would equal or be equivalent to the knowledge and skills portion of the TEKS, and B would be the student expectation. Okay. Next, we're going to be looking at the structure of the TEKS. We're going to skip the text at the top. We'll go to that in a bit. Let's start with the graphic at the bottom. Okay. So we're going to start off with the strand. The strand is the subject or the overall idea of what you're going to be teaching. So when you look on your TEKS, you should find that it either says science or it says history, reading, writing, or it's going to state the overall idea along with the subject that goes hand in hand. Next is going to be the knowledge and skills statement, which follows the strand. This is what the students should understand, what they should have an idea of already, what they should be going into this TEK with this predisposed thought or predisposed action. And lastly would be the student expectation. These are what the students should be able to do with that TEK, okay? And that is broken down into more specificity, okay? So we start off with our most broadest term, which is our subject or overall idea. Next, it gets a little bit more specified with our knowledge and skills statement. And then finally, we have our student expectations of what they are able to do. A lot of times what people do is they associate the knowledge and skill statement with the nouns of the entire TEK, and the student expectations are associated with the verbs of what they can do. Okay, so we all know that a noun is a person, place, thing, or idea. We're able to find those TEKs, and we're going to be going we're going to be going over those in a bit on how we deconstruct or unpack the TEK. We're able to go into that TEK and find the nouns that are within that TEK, and the verbs. We label them two different ways so that way we can understand what it is truly that this TEK is asking us to do. Now, if we look up at the top at the text, I went ahead and highlighted red, purple, and green. I'll tell you exactly which ones go with which. So our scientific investigation and reasoning is going to be our strand or our overall idea. I also like to say our overreaching concept. This is what the whole premise is about of the TEK, scientific investigation and reasoning. Next in purple is going to be our knowledge and skill statement. The student uses scientific practices during laboratory and field investigations. The student is expected to, and then lastly we have in the green text, plan and implement comparative and descriptive investigations by making observations, asking well-defined questions, and using appropriate equipment and technology. That green would be our student expectation. So that is actually one part of the TEK. There are multiple parts that follow that, and these are all the different expectations or what the student is able to actually do with that TEK. Next, we're going to go over what is the grand scheme. The grand scheme of these TEKs, of these state standards that are implemented by the Texas Education Agency. So starting off on the left side of the graphic, we have state standards, going to curriculum mapping, going to unit of study, and finally with district curriculum. We're going to be starting off with the state standards first. The state standards are these TEKs that we are unpacking today, and also the TAKS, which is now called the STAR. This graphic may be pretty old, but it's still relevant to this day that we can replace the word TAKS with STAR/EOC objectives. So these are the state standards. These are standards coming from the state of Texas. This is what our kids should be learning. So from K to 12th grade, each grade level is implemented these TEKs, or these Texas Essential Knowledge and Skills. All of these TEKs are things that we should be hitting throughout the year so that they can be prepared for the next grade level. All the way up to when they hit 12th grade and they exit school, they should have a good general understanding of the way things work by hitting all these TEKs. Next, we have curriculum mapping. What you see there, we have these two terms, the YAG, or year at a glance, and scope and sequence. These terms here encompass when and how long should the things we teach take to be covered. So a year at a glance shows us if we're, depending on what kind of structure your school district is. Here we obviously have a 6 weeks, a year at a glance. So we're able to see there from the first 6 weeks all the way to the 6 weeks, what units we should be covering, how long it should take, and that's where our scope and sequence sets in. It gives us a general timeline of how long these certain points should be taught. Some TEKs may be very fast. Some TEKs may take a little bit longer than others. But nonetheless, they are structured in a certain way so that they fit within the time frame of the school year so that we can go ahead and hit these high points. Next, we have our unit of study. So these are the learning targets, the instructional strategies, essential questions, and continuous assessment. These are the units of study. These are what makes up that of what we teach. And lastly, we have our district curriculum. These are the unit of study for all objects, or for all subjects rather. This is the disseminating of curriculum developed by the local district. So each local district is able to develop their own curriculum, but we have to follow the standards that TEA sets for us. So that is up to our our head of curriculum department, and curriculum writers here at the school that help to determine which curriculum is best for this district in order that we can follow also at the same time the standards set by TEA. So that way we can go ahead and make sure that all of these points are hit, and we're encompassing all the things that the TEKs are stating forward, so that we can go ahead and have a, very productive year for our students. This slide, we're going to be talking about what TEKS we're going to be focusing on. For this particular Unpacking the TEKS training, I went ahead and chose 2 TEKS that I hold dear, and I feel that they really play a big important role in how our students progress throughout the years. Not only in science, but also in all core subjects as well, and I will get to that in just a bit. But I chose TEKS 8.2a and 8.2e. With these TEKS, 8.2a is the student uses scientific practices during laboratory and field investigations. And with TEKS 8.2e, the students will analyze data to formulate reasonable explanations, communicate valid conclusions supported by the data, and predict trends. Now, what I've noticed as a teacher for the last 2 years and as a para for the last 5 years, 5 years before that prior, I noticed that with students, the biggest thing is having them conduct reasonable research or utilize steps in order to obtain the answer that they're looking for. A lot of times students get very anxious and they just want to pick an answer, or they give up very easily and they don't know what to do with the information at hand. And I believe if we can go ahead and put some emphasis using these 2 TEKS in particular in getting them to utilize steps and utilize tactics in order to find the answers that they are looking for, they'll be able to be a lot more successful in their endeavors, not only in science, but like I said before, in all other core subjects as well. It pertains to a bigger picture so that these students can actually use data, they can use what they've learned, they can use what's in front of them in order to find it may not be the correct answer, but it's going to be as close as they can to being correct. And they're going to utilize all avenues so that they can say, I did what I had to do to find the answer to this question, and I believe that this is the right answer. Unpacking the TEKS. To unpack the TEK, another word for unpacking is to dismantle or disseminate what's going on in this TEK. First, what we're going to want to do is we're going to want to choose what TEK we're going to want to unpack. After we've chosen the TEK that we're going to want to unpack, we're going to want to circle the nouns and underline the verbs that are within this TEK. These are going to help us put apart and put to the side which is the knowledge and skill statement and what is the student expectation. Next, we're going to want to state the overreaching concept. What's the main point of what's going on here in this TEK? It's also found in the strand. So if you're having a hard time disseminating what the strand means, you're going to want to state your own overreaching concept so that you can, in your own words, in your own eyes, see what you want to be the main point of this TEK. Next, we're going to break down objective to applied deconstruction. So once we get our objectives set, we're going to want to break those down and so we can apply it to each and every concept so that way we don't miss any point of this TEK. Next, we're going to want to analyze all the academic vocabulary that's going on in this TEK, because some things that may mean certain things to me may mean something else to another student or to somebody else. I want to make sure that this academic vocabulary is broken down so far that we can all be on the same page when we are administering these TEKs. And lastly, we're going to want to derive a measurable objective. We're going to want to see what we can measure and how we can go about that and figure out what we're going to do with this TEK and how we're going to go ahead and implement it into our curriculum or into what we are teaching, rather. Unpacking of TEKS 8.2a. The student uses scientific practices during laboratory and field investigations. I went ahead and circled student, scientific practices, and laboratory and field investigations. These are going to be my nouns that I have identified in this TEK. After that, I went ahead and underlined the only verb that I could find in this TEK, which would be uses. This is going to help me separate the two so that way I can tell which are going to be my knowledge and skill statement and which are going to be my student expectations. Because remember, going back to the slide previous, in the fourth slide, we were able to pretty much put to the side that the nouns are going to be the things that the kids should know, and the or the knowledge and skill statements, and the student expectations are going to be the things that they do, or the verbs. Next, I want to find my overreaching concept. So the overreaching concept that I found in this particular TEK are scientific investigation and reasoning. Once I have that overreaching concept, I know exactly what it is, the main idea of this TEK is going to be, and I can go ahead and break down further or unpack this TEK into its key vocabulary. The key vocabulary that I've identified in this TEK is going to be scientific practices and laboratory/field investigations. Once I've identified the key vocabulary, I'm going to go ahead and break down into my objectives. Now, the objective is also stated at the very top. The student uses scientific practices during laboratory and field investigations. But if you're a new teacher or you're somebody who looks at this TEK, you may favor one over the other because they are in the same sentence. If we break down this objective, we're able to find that it can be split up into two separate objectives. One being the student uses scientific practices during laboratory investigations, and also the student uses scientific practices during field investigations. That way I have both of these breakdowns stated on this slide. I'm able to not favor one over the other and able to hit two objectives rather than just seeing the TEK at the top and hitting maybe just one or more than one and less than the other. Unpacking of TEKS 8.2e. The student analyzes data to formulate reasonable explanations, communicate valid conclusions supported by the data, and predict trends. In this TEKS, I went ahead and circled data, explanations, data again, conclusions, and trends. These are the nouns that are going to help me separate from the verbs. I have also underlined analyze, communicate, formulate, support, and predict as my verbs. As stated in the previous slide, this is going to help me separate my knowledge and skill statements from my student expectations. So that way I can see what the students need to know or what they should know and what the students need to do. The overreaching concept that I have found in TEKS 8.2e is also going to be under scientific investigation and reasoning, same as the previous slide. The key vocabulary is going to be explanations, conclusions, and trends. Breakdown of the objective is going to be that the student analyzes data to formulate reasonable expectations. The student analyzes data to communicate valid conclusions, and the student analyzes data to predict trends. Same as I said before in the previous slide, breaking down these objectives into three separate sentences helped me to make sure that I go ahead and I hit all these 3 points all equally. I want to make sure that I don't leave out one and that I stress more than the other. So that way, when it comes time to it, when it comes time for the STAR test, when it comes time to for any assessment, the student knows that they are able to predict trends, they're able to communicate valid conclusions, and they're able to formulate reasonable expectations. They won't be lacking any of these because I went ahead and unpacked the TEK, and I was able to hit all three in this breakdown of the objective. Here's some background data for implementation of TEKS 8.2a and 8.2e. As you can see in the charts, I am showing you 8th grade Science STAR data from 2018 and in 2019. In 2019, the Science STAR special population data, there was an increase in the number of students who scored in the approaches category. Although to some this may not seem like a big deal, this means that we are also decreasing in our meets category from the years prior. We want to make sure that we are moving in the right direction and that we are decreasing our approaches standard or our scores, and we are moving over and increasing our meets and mastery level. We want that to increase rather than our approaches. When we are increasing our approaches, that means we're taking a step back. As you can see in this special population data, the group that we're going to be focused on for this implementation of Unpacking the TEKS is going to be our economically disadvantaged special population. In Meyer Green Middle School, we have a tremendous number of kids who are labeled under the economically disadvantaged special population. So we want to make sure that we are helping this special population also because the amount of kids that make up this special population are also our ELL and ESL kids. So when we can knock out two birds with one stone and we can help our kids that are labeled under economically disadvantaged, we are also helping our kids that are labeled under ESL. Next, why would emphasis of TEKS 8.2a and 8.2e be beneficial to children not only in science but also in other subjects as well? So, when we teach our kids to figure out the answer to a problem, we always try to guide them in a fashion that implements problem-solving skills. For example, in the next slides, we see each core subject with its own version of problem-solving skills that help guide the student to choose the most seemingly correct answer they can. So, like I said before, in each and every classroom, the main objective is to get the kids to utilize problem-solving skills so that way they can choose the correct answer, or they can find the correct answer rather. A lot of times people would like to associate learning with memorization, and that is not the case. What should consist of is leading our children to being able to work for themselves, to find the answer themselves, utilizing all the problem-solving skills that we have taught thus far. First, we're going to start off with math. You can see here in this image right here, we have the word PEMDAS. PEMDAS, as many of you know, it helps the student figure out the order of operations in order to solve mathematical expressions. It is a set acronym that involves the students to use reasoning and problem-solving skills to solve an expression and find the correct answer. Just like in TEKS 8.2a and in TEKS 8.2e, the student uses, I substituted the word here, with mathematical practices during investigations to formulate reasonable explanations and communicate valid conclusions. So just by me switching the word mathematical from scientific, we're able to still have a fluent and precise TEK that would be applicable to math. Now, whatever subject I want to take, if I want to take writing, if I want to take reading, if I want to take math or science, I can just substitute that word mathematical for scientific, or for whatever core subject I want to teach, and I'm still going to come out with a very viable TEK that's able to be assessed in all core subjects, and it's able to be a very big part of how they're able to find the answer to their problems. Next, we're going to see how these TEKs can be used in writing. In writing, there is a process regarding the composition portion of instruction that includes pre-writing, drafting, revising, editing, and publishing, as you can see there on the left in the graphic. Just like in TEKS 8.2a and 8.2e, the student formulates reasonable explanations and communicates valid conclusions. Having reasonable explanations and valid conclusions are very, very important aspects of writing, in that it helps to make your writing more concise and clear, and that you can go ahead and be able to get your point across to the reader, and not have any slip-ups, or not have anybody wondering where you are, what's going on, what's happening with this sort of with this essay or with this composition, where's the main idea, where's the setting, so on and so forth. When we're able to formulate reasonable explanations for our writing and communicate valid conclusions to our writing, we're able to have a more concise and more better form of writing than if we didn't use those attributes. So you can see here, I didn't have to replace the word writing in the TEK. It's already implied in just the explanation itself. It can be used for both writing and scientific purposes. Now we are in reading. In reading, there is a process that is taught. It is most similar to the scientific method in that it helps students garner a greater understanding by following these 7 steps. Now in the graphic that you see there, we have predict, visualize, question, connect, identify, infer, and evaluate. These are all things that can be used, or all strategies and steps that can be used for our children to use in their reading passages, so that way they can get the most out of what they are reading and understand it to a T. Now, when it comes to answering the questions, a lot of times what happens is that some students may fall victim to not utilizing these strategies. And so they may miss a part. They may not know what it is to predict. They may not know what it is to connect. They may not know what it is to evaluate when it comes time to use these certain verbs in our answer choice or in our questions, because they are going to run across these terms here, or these verbs here in their answer choices. And if we do not hit these reading strategies, they're going to fall victim to choosing the wrong answer. So just like in TEKS 8.2a and in TEKS 8.2e, the student uses reading practices See where I went ahead and replaced the word scientific with reading. Reading practices during text investigations, and the student formulates reasonable explanations and communicates valid conclusions. This can still be used as a concise and clear TEK. Even though it's utilized for science, it can still be utilized for reading. So that is why I believe that the scientific method of these TEKS 8.2a and 8.2e, as you can see in these last slides, they do play a role in not only science, but they also play a role in other core subjects as well, and they can help throughout that whole process of tackling these problem-solving skills. Now we're in science. As you can see in the graphic here to the left, I have included the scientific method. We have question, research, hypothesize, experiment, test hypothesis, and draw conclusions. I went ahead and gave you a quote from Oxford Languages, which states that the scientific method is a method of procedure that has characterized natural science since the 17th century, consisting in systematic observation, measurement, and experiment, and the formulation, testing, and modification of hypotheses. This falls hand in hand with TEKS 8.2a and 8.2e. So, with 8.2a, the student uses scientific practices during laboratory and field investigations. And in TEKS 8.2e, the student analyzes data to formulate reasonable explanations, communicate valid conclusions supported by the data, and predict trends. I utilize the scientific method of very, very much so in all of my labs and all of my processes in the science in my science classroom. And I believe that when we use these problem-solving skills, whether it be another name in math, just like PEMDAS, or we may have the writing process or the reading process or any sort of problem-solving skill set that we can use to find the answer, I believe it all is one and the same. I believe that we are just utilizing these steps in order to find the correct answer with whatever data, with whatever is in front of us, and what we can use and what we know to formulate those answers at the end, in which we choose, whether something is A, B, C, or D. But I do believe that the scientific method and these TEKS 8.2a and 8.2e do play a big role in the science realm, and I do believe that they will help us in our lowest point, as stated in the data in the previous slides. I do believe that this is going to help our lowest group. If we hit these points, it's going to help our lowest group rise, and as we're going to be able to hit those masters and meets scores when it comes time to take the STAR test. As we start concluding this training on unpacking the TEKS, I just want to throw out some importance of scientific investigation and reasoning and the scientific method. I saw this online. I thought it was a very good, important tidbit to throw in there, and where it stands, not only, like I said, in the scientific portion of our classes, but in our everyday lives, we always utilize some sort of problem-solving skill, whether it be fixing our car, whether it be trying to figure out a problem in the yard, trying to figure out something with our scheduling. There's always some sort of a problem-solving skill that we have to utilize in order to tackle these everyday problems. And something that I found online with the American Journal of Neuroradiology was that one of the most important features of the scientific method is its repeatability. The experiments performed to prove a working hypothesis must clearly record all details so that all others may replicate them and eventually allow the hypothesis to become widely accepted. Objectivity must be used in experiments to reduce bias. Well, we all know that bias refers to the inclination to favor one's perspective over others. And I know I sound like a broken record going over and over this, but I do believe that when we utilize these problem-solving skills more effectively, we are able to not only just improve scores, which is what most people think of when it comes to public education. It's all about scores. That is totally not the case. We're trying to implement these problem-solving skills in our students so that they can thrive and become viable citizens once they leave the public education school system, and they're able to take these qualities with them so that they can go ahead and live a leading life and have all the tools at their disposal and maybe one day they'll figure out in their adult life that let's just say something's going on with the car, and let me figure out, let me stop, let me analyze, let me perhaps put a hypothesis to something. Maybe it might be this. Let me check it out. Let me run some tests. Let me get some data. Okay, it did this when I performed this. Let me come to a conclusion as to what the problem that I was having with this car turned out to be not the problem at all. So they were able to take these qualities, for example, and just use them to the best of their abilities, and hopefully for the greater good of the world. So research-based practices in favor of TEKS 8.2a and 8.2e. As stated by the American Chemical Society, hands-on laboratory science experiments are critical to the learning processes across all areas of study, beginning with kindergarten and continuing through post-secondary education. Research has shown that students who engage in well-designed laboratory experiences develop problem-solving and critical thinking skills, as well as gain exposure to reactions, materials, and equipment in a lab setting. Well, I think Coach Acuna, and I thank you to Elisa Garza for participating in this Unpacking of the TEKS training. I hope that what you took from this is able to help you in utilizing or unpacking the TEKS in your own classes, so that way we can go ahead and work as a team in building on those TEKS and making sure that when my kids end up hitting, Coach Acuna's class, for example, and when Elisa's kids end up hitting my class, all these TEKS were hit at one point, and they're well versed in them, and they're able to utilize these TEKS over and over again, and sustain that good academic rapport that they have when these TEKS are all fulfilled. If we leave any of these TEKS out, I fear that when they get to my class, or if they get to Coach Acuna's class, your class, that they're going to be lost. And I don't want that to have to fall back on me and my lack of not having to implement these TEKS, or my lack of not unpacking these TEKS as I should have. So I thank you all again for participating in this training. Thank you very much, and have a good day.